Hi, I'm Elise Estep,
Hi, my name is Kyungmin Kim.
and welcome to our ArcGIS Atlas-builder for BYU 514 Winter 2017.
So problem statement is to connect the Frontrunner station in Provo, Utah to Las Vegas. So this is project to find out the best railroad way from Provo to Las Vegas. To complete this project, we gotta consider 4 things. First one is terrain, especially to avoid high slopes. So the normal slope which is allowable for the railroad is the 2% and maximum about 4%. So we gotta consider the slope of the railroad way. And second one is avoidance of water body requiring large bridges, because large bridge require for the construction, so we gotta avoid the large body of bridge. And third one is existing railways and highways. So to make the efficient railroad, we gotta consider the existing railroad and highway. And of course, the fourth one is shortest cost of this distance to find out the best and efficient way to the Las Vegas. This is page for existing condition. So between Provo and Las Vegas, there is one railroad and several roads we have to consider about for this project. And the tropical condition is there. On the east south side, there are a lot of the mountains located, and there are about 3 big lakes we have to consider. And data collection. For consideration, we have to download the several files from the authorized website. So one is DM files. It helps us to consider the slope of the land, so we can find out the best slope for the railroad. So DM file was downloaded from the national map website. And also road and railroad and cities were downloaded from that website to find out the best railroad way from the Provo to Las Vegas. Also, the DM files was merged to complete this project. Left side of the picture is the DM file. Right one is all the existing lakes and streams we have to consider for this project, and each from the Utah website.
So, moving now to our template. It's called All Roads Template, and when you open it, the stations we have pre-programmed are available there for you. If you want to, you can change these. The tool is in the toolbox. It's called All Roads. Featured on the screen are some other tools we developed to test bits and pieces, but they will not template when you open the All Roads tool. You will see many, many inputs. The first few are all feature classes that are stored in the geodatabase. So when you open them, they should be listed here. And railroads is called rails. Everything else should be named exactly the same. You are free to replace these with whatever railroads or highways or lakes you have. They will still work. We have provided the ones that are included in the area between Provo and Las Vegas. The slopes raster was calculated using the slope tool from the merged DEM file shown previously. The merge on the DEM took 11 hours to process at the original cell size, so if you have your own and pre-process it on your own time, you are welcome to use it. Otherwise, we recommend using the slope template. So start at Provo, and then for your ending point, there are 3 optional choices. We will choose the MGM station in Vegas for this run. Use the All Roads database for your geodatabase. This project has been set up in North America NAD 1983. The cell size from the original DEM was modified slightly. We have been doing 0.005 for our cell size. The cover page folder is where your cover page is stored. It won't show up here, but if you were to open the File Explorer and go to that folder, you would see a PDF called Cover Page. You are welcome to make whatever cover page you like. Just make sure you've named it and you know where it is. And then you hit OK. The first few steps run rather quickly, and then it gets hung up on buffering the lakes class that we've used. So out of the 24 minutes it takes to run the tool, about 16 of those are buffering the lakes layer. So you can see that they're trimming. And we're skipping ahead now to the end. So you can see the elapsed time was about half an hour. If you go to your output folder, you can see the printed PDFs. So we click on the All Roads one, you can see our cover page, and then go down through the different cases. Each case was configured with a different cost, as we'll go over in the code in a minute. And as you can see, the different paths are different. Although they are highly similar, there aren't too many different ways to efficiently get from Provo to Las Vegas. And now moving over to our code, we started off fairly simple. We imported ArcGIS, OS, and we moved on. We defined our current mapping project and our data frame. We loaded in all of those variables that you saw earlier. As you remember, the cover page needs to be named cover page. This is easy enough to change. It would mean adding another variable. The user could define their own cover page name. We set up our environments, allowed for overwrite of old files. Here we defined our global variables, and here is where we start listing the different costs. So for several of the inputs, lakes, highways, cities, and slopes, we assumed that they would be a consistent cost. Lakes are always expensive to cross, so are highways. Cities are always good to stop in, and the slopes 10 is desirable, 2 to 4 is okay, and anything higher than 4 is just too expensive. Below that, we set up an array of arrays to define the costs for railroads and for the rivers. We set railroads to be able to go through a combination of being desirable, neutral, or something you'd want to avoid, based on whether or not you were able to procure rights to existing railroads. For streams, we balanced it between a cost of 2 for neutral, it's not a big deal, you can cross it, or 10, too expensive. We have also built an array for the different names of the different cases, 1 through 10. Moving on, we see the only function that we built specifically for this one, and the function trims whatever input class to another input class, specifically a polygon. Originally, we had written code that tried to trim the input feature class by a polygon created to fit the extents of an input raster, but we never quite figured that one out. So instead, it requires its own input polygon. We also take care of some pre-processing. We select the major lakes and rivers to try to decrease time. Even still, the major lakes file takes a long time. After the pre-processing, we go to trimming our inputs. We send each input file through the trim function we defined. Those trimmed files are then buffered. As you can see, there are a lot of add messages here so that each step can give notice when it's finished. After they're buffered, the resultant polygons are converted to rasters, and those rasters are reclassed based on the arrays above. After the reclassification has taken place, a PDF is started. It checks for an existing PDF of the same name to clear it out before it creates a new one. The first step is to append the cover page to the new PDF, and then for each case, a variant reclassification is performed for the railroads and the streams. It's different for each case. And then using those variant reclassified rasters with the constant reclassified rasters, a total cost raster is calculated, which is fed into a calculation for cost distance and then a cost path. The cost path is then converted into a polyline and added to the map. The map is then appended to the PDF and exported separately as its own PDF, and then it's removed so the legend on the layout view doesn't run into the world imagery. The elements on the layout view are updated by their element names, and they're updated according to the values in the arrays for that case. One important step that we found was to refresh the table of contents and refresh the active view. Without them, the map did not print correctly. Between the original Provo front runner station and the 3 optional endpoints in Las Vegas, there is a potential for 30 different maps. However, the paths are largely the same between the points, since the endpoints are within the same city. And that's it. Thanks for watching.